Hi everyone. So this is my presentation for the AI course. My topic is why anthropomorphic AI will outperform most rationality-centered AI in the future. So let me get right to it. Um, as mentioned in our course book, AI itself can be defined from two different perspectives: the perspective of rationality and the perspective of anthropomorphism. In AI, anthropomorphism is concerned with the AI's fidelity to human performance. That means that how closely the AI would resemble what humans would do in that domain. Um, on the other hand, rationality is concerned with having the AI perform as ideally as possible under that domain. So this means that in domains like either, let's say, chess or mathematics, the AI will perform the perfect, will mimic the behavior of a perfect being, and whether or not that being is a human or some other sentient life form. Uh, okay, now that at least my title makes sense, let me start off by describing how computer AI was generally made. So what happened was that computer programmers traditionally used to implement the logic of AI games by themselves. So the computer programmer's task was to design code such that the code would perform well under each domain. Now, this code did not necessarily need to replicate human behavior. In this presentation, when I refer to a rationality-based approach, I talk about these kinds of approaches in making AI. This approach was traditional and it used to dominate most of AI creation. However, nowadays we are seeing a completely different trend in developing AI. Now, this new approach generally uses machine learning and is mainly concerned with replicating human-like behavior in certain domains. So my main thesis in this presentation is that we will increasingly see anthropomorphic AI outperforming the traditional rationality-based AI in many domains. So let me start off by giving a history of AI and how the traditional rationality-based approaches uh, worked within 5 domains. So the first domain I want to talk about is the game of chess. In 1999, IBM's Deep Blue defeated Garry Kasparov in a 12-game match, marking it the first time that a human beat a world champion in this game. So how the AI worked was that it brute forced every game state through the alpha-beta search algorithm and assessed positions using a handcrafted evaluation function. So what it had was human developers handcrafting variables to assess positions. Now in those days, the strength of the AI primarily relied on how good the handcrafted evaluation function was. So Deep Blue was better than its predecessors because the handcrafted functions that the programmers created outperformed its predecessors. So the game of chess was conquered by AI primarily through the improvement of the handcrafted function while still using the traditional rationality-based approach. So that was good enough for chess. So let's see another domain, which is the game of Go. So in the game of Go, the same approach as the Deep Blue algorithm in the game of chess was not yielding promising results. The main reason for this is that in the game of Go, there are a lot more moves to consider than in chess, and this resulting in the AI being overwhelmed even after a small depth. The reason for this is that in the game of Go, there are a lot more moves to consider than in chess, and this resulted in the search algorithm not being as not being able to search as deeply as it needs to. So the traditional rationality-based approach had issues with the game of Go. So another domain I want to mention is robots playing table tennis. So early programmers needed to consider factors such as air resistance, the Magnus effect, and implement them in the AI such that the AI would perform reasonably well. However, this approach again had issues with the game, and this did not yield in very good AI to play the game of table tennis. In many of these domains, we see a common problem. One is that it becomes exceedingly difficult for the computer programmer to improve the logic ingrained into the computer program. If you change one aspect of the program, there was a risk that another aspect of the program would break as well. And also, humans attempted to create physical models for the programs. However, there would always be edge cases that the physical models would not consider. For example, in chess, if the DeepMind algorithm was able to beat Garry Kasparov, the same algorithm was shown to struggle in many chess positions that a human grandmaster would easily be able to solve. So as we can see, there were issues with the logic-based approach and having the programmer handcraft each and every variable such that the AI would perform ideally in a certain domain. But nowadays we are seeing a completely different trend. This trend utilizes machine learning algorithms, and the central goal of many new AI is to replicate human behavior in those domains. So let me start off with an example. So in March 2016, AlphaGo beat Lee Sedol in a 5-game match, being the first AI to beat a human world champion in this domain. So how the AI worked was that instead of using a brute force algorithm like alpha beta and using a handcrafted evaluation function, it had a completely different approach. So firstly, it used the Monte Carlo search algorithm instead of the alpha beta, and for the Monte Carlo search tree, it also implemented a neural network that outputted the favorable actions in positions. Another was that a multi-layer neural network was used for the state evaluation instead of a handcrafted evaluation function. So how the AI worked was that the research team trained the AI in thousands of human games, and using that training, the AI was able to have a good evaluation neural network and also the good evaluation neural also a good neural network for the Monte Carlo search tree, and doing this, it was same team that same so continuing this development in 2018, the same team that created the AlphaGo algorithm published a paper showing improvements on their creation. This time they even extended their domain to the game of chess. So this approach was different than the 2016 version in that the network did not learn by looking at existing human games, but rather by playing against itself and learning from its own games. So by this approach, in the game of Go, the algorithm outperformed its predecessor from 2016. More interestingly, in the game of chess, this approach resulted in the strongest chess playing algorithm ever created. It decisively beat the previous Solquist AI. It decisively beat the previous strongest AI, something that was created using the rationality-based approach that I talked about earlier, in a 100-game match. Moving on, let's talk about table tennis. Now, there's another algorithm. In their paper, Learning to Play Table Tennis from Scratch Using Muscular Robots, the team detailed the creation of an AI that would take a camera input and learn to control its actuators to play table tennis. This approach was derived. This AI was derived using the AlphaGo and AlphaZero algorithms that the DeepMind team had created. This approach resulted in a very successful AI that showed to be capable of returning 95% of the balls successfully. Another interesting domain is the game of Dota 2. In 2019, OpenAI created an algorithm that beat the best players in the esport game of Dota 2. Again, in this approach, they used reinforcement learning to train the AI how to play the game. The architecture of the AI itself was inspired from the AlphaGo algorithm from 2016, and how they created the AI was very similar to AlphaGo. Now moving on, let's talk about an exciting breakthrough in the field of structural biology. In structural biology, the protein folding problem is very important. So let me explain the protein folding problem. So proteins are made up of singular long chain of amino acids. These long chain of amino acids are unstable by themselves, so they fold to form a certain 3D shape, and these result in proteins. However, it is very difficult to predict what shape a certain amino acid chain will result in, and AI researchers have been focusing on this particular problem for many years. The CAPS competition was designed to benchmark the predictions from different teams across the world. So in 2018, DeepMind achieved very successful results on the competition using the same algorithm that they used in AlphaGo and AlphaZero. This was called AlphaFold 1, and it achieved a success rate of 50% in the competition. This was the best result any AI had ever gotten. In late 2020, they actually improved their performance by a lot, creating an AI that reached a performance of 90%. This AI was called AlphaFold 2. So as we can see, in the past decade, there has been exciting development in the field of AI. Ever since AlphaGo, the anthropomorphic AI have been outperforming the traditional rationality-based AI in many domains. The issues we had with traditional rationality-based approaches will be rectified by this new type of data-driven and machine learning AI that is primarily focused concerned with replicating human behavior in certain domains. So this is where I conclude my presentation. I am very excited to see what the future holds in the field of AI given the current trends. I hope that this presentation resulted in some of my excitement rubbing off on you as well. Thank you very much.